Good morning to all. In this slide, we are going to see the basic concepts of dyes. Dyes, they are chemical substances which are used to adhere to whatever the objects we wanted to color. For example, we can use the dyes to color paper object, cosmetics, plastics, cotton, wool, and various textiles. These are the chemical compounds which contains functional groups like azo compounds, anthraquinones, etc., which are responsible to impart the color of the dye. Colorants are few pigments which usually contains metals and preferably transition metals. They are responsible for imparting prominent colors to the objects. For instance, copper through the malachite green they impart color to the objects. For example, iron, which is technically known as Prussian blue, they impart color to the objects with the blue color, which can be altered to yellow, red, magnetite, etc. Chromium, they impart green color through the compound chromium oxide, chromium yellow, etc. And using these transition metals in the pigments, they have ideal properties. That is, they are chemically inert, they have good fastness, they are insoluble as possible, they give vibrant colors, they have uniform particle size, and the very special ideal property is that they have high opacity or hiding power. These are the few terms which is essential to keep in the mind when you study the basic concepts of dyes. Chromophores, oxochromes, bathochromic shift, hypsochromic shift, hypochromic shift, hypochromic shift. We'll start with chromophores. The chromophores are the basic compounds which contains C double bond C, C double bond O, N double bond N, C triple bond N, etc., which has pi electrons. These pi electrons are highly essential as they give the delocalizing effect, and these effects are responsible for the whole compound to impart, or they are capable of absorbing UV or visible light, and they impart the specific color to the objects. And next, passing over to oxochromes. These are the functional groups, or else they can be called as the mere substituents. They are the functional groups, they have the ability to just shift the color of the chromophore. That is, the for instance, if the color of the chromophore is red, or if the color of the chromophore is orange, you can add the oxochrome and you can alter the color from orange to red, or from orange to blue, or from orange to indigo. So the oxochromes are the functional groups which can alter the color of the chromophore. But you have to keep it in mind that oxochrome itself cannot impart color to any object. Oxochromes in turn are just the functional groups. When added to the chromophores, they can alter, that is, they can shift the colors either towards the longer wavelength or towards the lower wavelength. Next, the important thing to be determined is bathochromic shift. It is otherwise called as red shift. When you're adding the chromophore for any color change, if addition of chromophores alters the color of the dye, if it alters towards the longer wavelength, then the shift is called as bathochromic shift. Passing over to hypsochromic shift, addition of any oxochrome. That is, if you are adding any functional group as oxochrome to the chromophores, if the shift of the color is towards the shorter wavelength, then the shift it is called as hypsochromic shift. The bathochromic shift is otherwise called as red shift. The hypsochromic shift is otherwise called as blue shift. The mere addition of chromophore when if when the essential color is yellow, for instance, if the color is highly intense, the color may shift from lower to the longer. That is, the absorption of the color is high. If the absorption is very intense, it is called as hyperchromic shift. If the absorption is lower, it is called as hypochromic shift. In other words, the hypochromic shift gives very pale or lighter colors, and the hyperchromic shift gives intense or dark colors. This shows the electromagnetic spectrum of the colors which are arranged with respect to that of the UV and visible light. In the visible region, which has the wavelength from 400 nanometer to 800 nanometer, all the color ranges from violet to red are arranged as per the absorption wavelength. Everybody knows the Vibgyor range, which has violet, indigo, green, yellow, orange and red, and accordingly the color absorbs from lower wavelength to the higher wavelength. So this is the basic concept which you have to keep in mind when the chromophore is added. If you wanted to add a oxochrome to shift any color towards the lower wavelength, the colors will absorb at the range of 400 to 500 nanometer when the color is very pale. If the color is shifted towards the higher wavelength, then it is known that the color of the dye is getting intense. Thus, on the other hand, this diagram will show you the clear absorption range. When the dye color shift towards the lower wavelength, it is called as hypsochromic shift, and when the color of the dye shift towards the longer wavelength, it is called as bathochromic shift. Accordingly, when the color of the chromophore is highly intense, it is called as hyperchromic shift, and when the color of the chromophore itself is less intense, the peak which is given in this slide shows the hypochromic shift. So, the groups which are essential for altering the color is clearly known as oxochromes. And this slide shows the difference or the essential points of chromophore and oxochrome. The crispier data of this presentation is that chromophore is the molecule which is solely responsible to impart color to the molecule, whereas oxochrome is the functional group or any attached extra atoms to just alter the color of the chromophore. For example, chromophore contains azo groups with N double bond N or C double bond N or N triple bond N groups. So these are the groups which are responsible for color of the compound. And some examples for oxochrome are that hydroxy groups, all the halogen groups starting from chlorine, bromine, iodine, etc. And also a few examples which encloses the nitration reaction is that the clear benzene itself gives a pale yellow compound, whereas the addition of nitrogen alters the product as nitrobenzene. Hence, the color changes from pale yellow to intense yellow color. That is, on other words, the addition of nitro group as the oxochrome will shift the color from pale yellow to dark yellow. This is the essential slide which is published in the research paper, which shows the applications of various dyes which is used in the day-to-day life used products. So there are many dyes, that is many chromophores along with the oxochromes, which are categorized as reactive dyes, acid dyes, azo dyes, basic dyes, sulfur dyes, modern dyes, direct dye, dispersed dyes, and all these structures has chromophores, that is C double bond O, C double bond C, N double bond N, N triple bond N, etc. And there are the functional groups which is attached to all the chromophores. They are called as oxochromes. So these oxochromes alter the color either towards the shorter wavelength or towards the longer wavelength. And using all these dyes, many applications are listed in this picture, that is starting from the cosmetics to the textiles to the day-to-day life, ink, woolen papers, silk, plastic bags, etc. Thank you.